Oh yeah.
Okay. Right, folks, I was thinking of having a look at the Stats 1 exam. I mean, what do people think of it?
Awful.
That's alright. I found it alright actually.
You found it alright, Jack?
Yeah. Are you amazed?
No, I'm quietly chuffed, you know?
I was
It's good to hear that.
Alright, it's just time management wasn't that great. Somehow there's a lot of working out to do.
Well, it's just going to be more than
So if you had 2 hours to do it.
Yeah, I would have been fine then. But I didn't get up to question 9.
Where's the shower?
Oh, with the gas fire.
Yeah.
Okay. Well, what? That's what, 10 marks out of 72? Like, that's only 10% in the scheme of things. Like, if you did really well at the other stuff, it wouldn't make a difference. Right. Yeah, if. Right. I was thinking of us starting core 3 today, because we can. Okay? So, bring out some paper, bring out a pen and stuff. I've got a presentation. And I've got a card matching activity that may or may not work. Okay? So, we're going to be making notes and things. We're going to be taking it a bit like old school.
Just cut out. Back to geography. Don't feel as the best. Just put that like. What, Miss Johnson? Yeah. Today we're going to cut some stuff out and stick it in. That's an entire 4 hours of geography.
No, we had that time with Luke and he basically crossed.
Oh, folks, I know what. Can you get mini whiteboards and pens?
Cheers, Jack.
It's going to be one of those lessons.
Don't worry.
Yeah, do you have pens and erasers? Because I'm going to be asking, like, not quick fire questions, but often. 2.
Yeah, I've got 4 pens. You got 4 of them.
Right, folks, once you got a board and, you know, you've worked out how to erase it and stuff with the erasers, can you, on a scale of 1 to 10, tell me what you thought about Stats 1? Like 10 being good, 1 being... Yeah, about the exam. You know, the actual exam as it went down, what did you think of it? You know, it's just a quick thing, it's just for my, like, curiosity.
Maybe 6 and a half.
Okay.
That's 6.
Alright. Ooh, okay. Right. So George, you... Okay. So guys, I'll have to see everyone's in about 10 seconds. Just a number between 1 and 10.
Get another board.
Randy, what do you need? Oh, you've got one. Am I intimidated by the camera? Maybe.
What's the camera there? Is it recording?
Yeah, it's recording me, and it's curiosity, literally. I realise I can borrow stuff from other departments, so if you see me with a paintbrush next week, then like, you'll know why. Now, what have we got? We've got 5s, we've got 7s, 6.5, 6. Right. Randy, if you could show me your number, what do you think? I can't even see that pen mark. Okay. Right.
It's alright.
Now, we're going to recap this, all right? This is just differentiation, okay? So, if I bring up a little screen shady thing, if y equals 10, if y equals x to the power of 10, what does dy by dx equal? Have a go at that. Pen on your mini whiteboard. I want to see what people are thinking. Right, 5 more seconds, 4 more seconds, 3 more seconds, 2 more seconds, 1 more second. Show me. Right. Ooh, are we good? Oh, we are good. That's good, people. Now, what's the answer to this? We're differentiating x cubed with respect to x. So another way of saying this would be y equals x cubed dy by dx equals what? That part's y, that part's y. All that I've done is stuck what y is into the d by dx thing instead of y. Okay, so you should be able to find the answer to this. It's just representing it in a slightly different way. So, another 5 seconds. I want to see what people are thinking. If you don't know, put a big question mark. 1. Okay, show me what you have. Just double checking what you do. Ooh, seeing a lot of. Okay, what are you thinking? Okay, so if y equals x cubed, dy by dx would equal 3x squared. So when we differentiated y, we got 3x squared. When we differentiated x cubed, we got 3x squared. So when we differentiate x cubed, we get 3x squared. Okay, it's just summarizing things, so we don't write that out all the time. It's got the question all in one place. So, have a look at this one, have a go answering this one. Okay? So mentally you can think about y equaling that. What does dy by dx equal? I'll count down from 10 in my head, okay? Now, has anyone got an idea behind this? Hold up your boards right now, just so I see what you've got so far. Okay, we've got some X's. We've got some question marks. Okay. All right. So, I'm going to break it down again, just like I broke that down. So if we had y equals x squared over 2, dy by dx would equal what, George?
2x.
Excellent. It would be 2x over 2. Let's simplify that.
Just x.
It's just x. So, we were differentiating x squared over 2 with respect to x, and the answer was x. So, over here, we're differentiating x squared over 2, and we get x. Just like we got over here. So, this part here is asking the same question as this thing here. It's just a more summarized form, and you'll be seeing that more and more often in Core 3 and Core 4, just to save space on the page often. So I've got at least one more example like that. Okay, so let's give this one a shot. Ooh, we've got more than one term now, but it's still the same idea as before. We're still differentiating 3x squared plus 5 with respect to x. I'll give you a 10-second countdown until I ask to see them, okay? Okay, I think everyone would have had to think about it. Can I see what you have? Okay, now we are cooking with gas. Everyone's got that absolutely fine. This is good, this is good. Now, because we're going with gas, I'm making it slightly more difficult. Ooh, what is that? What's different about this one? We don't have x anymore, we've got t involved. So we're differentiating t to the power of 4 with respect to t. So So have a go writing out an answer on the mini whiteboards. I'll give you a 5-second countdown, because I think you'll either get this or you won't straight off. 2, 1. Hold your boards up, let me have a see. Okay, that table's good, that table's good. Ah, brilliant. Okay, folks, I think we have cracked this little bit. Now, there's one more, and that's just me starting to mess with you because I've stuck in a different variable, a different letter. Okay, so try answering that for me. So we've got two terms. The first term is 4 times h to the power of 5. The second term is 2 lots of h. We're differentiating them with respect to h. So, give you a 5-second countdown. Right, hold them high, let me see. Okay, this is good, this is good, this is good, this is great. Okay, folks, can you get out paper and pen for me, please? I want us to write these down, okay? Now, at the minute, we don't have a title, so you could just call this recapping differentiation, okay? We've got a slightly new bit in. So, we're starting core 3, okay? Core 3. 3 for 3 headers. So we started off by just differentiating something straightforward, and then we had this new thing, this new notation going on. Now, I'm going to try and be smart and like zoom out a bit on this, so if you give me a sec, it might be worth your while. So zoom. Oh, that's nice. Guys, do you like that? It's all on one page. Can you still read it? No one's about to tear their eyes out at that? Okay. So, just take a box around that as well. Alright, so the things in the boxes are the equivalent of the thing on the left of it. Just, you know, both ways of getting the same answer. Right. When you're done, put down your pen so I know that you're done. Otherwise, thanks, Jack. Right. If you're done, think about this equation, okay? Think about how you might solve that equation. But you know, you don't write that yet, okay? I'm carrying that stuff above the dashed red line for now. Andy, are you done copying? Brill. Okay, folks, I'm going to show you this and I'm going to zoom back in because this is getting more to what we're actually doing today. Alright, but it's not as drastic as you might think. So, if you got asked that, okay, think about what you might do. So if you got told to create a curve so that the y value equals the gradient of the curve, what kind of curve could that look like? So the gradient of a curve equals the y value at any particular point. Now, I could go wild. I could just draw a curve, a made-up curve, and ponder about that. Now, I don't think that fits the bill, because over here, that's a negative gradient, that's a downhill gradient, but the y value there, let's say, is still positive. So, that is definitely not an answer to that equation. So, we could try out loads and loads of different things. We could be thinking, oh gee, we can never have a downward slope because then the gradient would be negative and we might just have a negative y value. You could start sketching things like that, but that doesn't help you. It's got a constant gradient. If it has a constant gradient, it should have a constant y value, but it doesn't. Now, people spent years trying to think about this because it seems quite a simple question at first until you start visualizing what it could look like. You know, the height equals the gradient. They're two simple things, we recognize them, we know about them. Really hard to work out. This went on for a while until the 17th century, until Leonard Euler discovered E. No, not that E. E is a special thing, it's not a bunch of pills in your hand. So, he's a Swiss man, and he discovered E, and the whole world was like, this man is the best mathematician of our time because of this. He's so good, in fact, we named it after his initial. So, as a title, write down, what is E? Now, E is a number. It's a very special number, and we're going to use it in a sec to answer the question we were just pondering. Okay, so E is a number. E equals 2.71 blah de blah de blah. It can also be written as the summation of 1 over n factorial. Now, the thing that we're really concerned about is the fact why E is so special. Because if we had e to the power of t and we try differentiating it, it exactly equals e to the power of t. Differentiation does not affect it. So, if I was differentiating e to the power of x, let's say, using our new notation that we brought up at the start of the lesson, that will just equal the same function all over again. Now, they called it e as a letter to save having to write down this big convoluted number. It's like us calling pi pi instead of always mentioning it as 3.1428571 and 14285. Okay? It's a shorthand. Now, E is for Euler. E is also for exponential, and that's because of this property. If you have a variable as the exponent, as the power of E, it doesn't get touched by differentiation. Now, if you've got that very important fact down, let's go back to the question and think about writing out an answer to this. So, get your mini whiteboards at the ready. We're going to sketch things. We're not going to put things in neat yet, but we're going to sketch out possible equations that will fit the bill to our question. So, am I okay to move on? Dean, are you alright to move on?
Yep.
Brilliant. Now, here's the question again. So, use E to come up with y equals something that fits the bill. So we want y to equal dy by dx, and we want to use E to come up with that. So using our fact about E, our special property about E to the something, what can we do for this? Have a go on your mini whiteboards. Have a think. Yeah, no, a very important fact, okay, and I've used T in that version of it, but I could have used any letter. I could have used H, could have used P, but I didn't, I used T. Now, what could we do with this? What could we write as y equals? I'll give you 20 seconds. Chat amongst yourselves, show each other your ideas, have a little think about it. You've got 7 seconds. Right, folks, can you stick up your whiteboards for me? I want to see what's going through your heads. Okay, some people are bang on. Oh, blimey, that pen is not good for my eyes. Am I supposed to be squinting at the top part? There's nothing. Oh.
Oh, if I was looking then, not.
Trick question. Right. Okay. All right. Now, quite a few people have written down y equals e to the power of x. So, let's test it. Let's see whether it fits the bill. Now, y equals e to the power of x. What would dy by dx equal? Well, first off, we can write it as d by dx of e to the x. Oh, using that, we can see that it differentiates to e to the x, and e to the x is y. So we are happy chappies. Now, this means that y equals e to the x fits the bill for this kind of curve. And it's a special curve. I mean, no other line can fit the fact that its gradient equals its height at any particular point. So it's called the exponential function. It's got an actual name for it. That's how special it is. So please, jot this down now on paper. Okay? Phrase it however you want. The important thing is to get across the fact that this is the exponential function, and this is why it's a special function. Okay? It's the only line that fits that bill. Then once you've written down on paper how you're going to remind yourself of this, go back on your mini whiteboards and think about drawing it. Because you might be able to have a good crack at drawing it. Jack, you can have a go drawing again?
Yeah, to a graph.
Yeah, have a go sketching graph. So we're going to draw an axis. Have a think about, what x and y coordinates would be on it, what the general shape of it would be. I mean, I don't think it would be downhill anywhere. We'd never have a negative gradient. Maybe something like that, yeah. Where would its y-intercept be?
Would it have one?
Oh,
It would be a 0.
would it? Think about it. Think about the fact that you can substitute in x values to find out what y is. And then think about whether, where it crosses the x-axis. Things like that. Yeah, so a sketch involves these key points where it crosses the axes and its rough shape. Okay, you're not particular about every single point on it. I'll give you another 10 seconds to have a go sketching things. You can put down multiple ideas. So Jack, you going to sketch an idea? Have a think. At the y-intercept, x equals 0. So we can sub in x equals 0 into that. We'll have e to the power of 0. E's just a number, remember?
What?
Yeah.